Jai Hind students, I Ayushi Gupta, Assistant Professor, Department of Computer Science at AKGEC Engineering College, welcome you all to the lecture series of Programming for Problem Solving. So student, today's topic is sorting algorithm. In the last lecture, we discussed about the searching algorithm that you have in your scope in the form of linear and binary search. And today we are going to discuss the sorting algorithm. So students, as I told you in the last lecture, that searching and sorting are the most basic and important operations that we need to perform on the data structure that we are having, like array. In our syllabus we have array. So like searching we did, and the procedure in the form of algorithm that we need to adopt and implement in the form of programming, that we studied in the form of searching algorithms. Now sorting algorithms, that is required for the purpose of sorting the data structure. What is the meaning of sorting? Clearly, we will try to understand in today's lecture, and how we implement and proceed with the sorting algorithm on the data structure array, that we will understand. So, the name of sorting algorithms that we have to discuss and understand are bubble sort, selection sort, and insertion sort. We are having three algorithms in our scope with respect to PPS. So students, let let us clearly understand what is the meaning of sorting, why we need to sort the array. So students, sorting, very simple meaning. Sorting means to arrange the data structure, or you can say the elements present in the data structure like array, in the form of some ascending or descending order. Sorting basically means you are arranging the data, okay? And the arrangement that we do in sorting is basically of type, either we arrange the data in ascending form or descending order, right? So that depends on the requirement, that what is the requirement of the user, that whether they want the data to be arranged in increasing order or the elements should be in decreasing order. That totally depends on our requirement. And sorting with this method, the algorithm provided by sorting helps us to do that. So sorting can be defined as the process of arranging elements either in ascending or descending order, and sorting arranges data, or you can say sorting arranges data in a sequence, which makes searching easy. Okay, obviously you can very well understand that once you have arranged your data in either ascending or descending order, and you need to search a particular element, that becomes very easy. Like in the last lecture we discussed binary search, and for binary search also we realized that we first need to arrange the data in ascending order, right? Once you arrange the data in ascending order, and if you need to search a particular element, then there is a clear idea whether we proceed to for the first half of the array, or we should look in the second half of the array for that particular element. So students, as I told in last lecture also, that like you are having three algorithms in your scope, and many more are also there. Many more standard algorithms are also there that are adopted in system for the purpose of searching and sorting. But we are having so many algorithms because they are on the basis of time taken by their execution and the memory space they are taking, that makes the algorithms better than the other, right? In certain scenario, in certain platform, one algorithm is suitable, the other is, but no algorithm is superior or less than the other, or best algorithm. They are best in terms of, in that scenario, what they are serving in terms of time and memory saving, right? So now we proceed to sorting, and sorting, as I told, the algorithm is the procedure of arranging the data in ascending or descending order. So simply, if you are having some random elements of array, like we are having 34, 2, 56, 14 and 9, then after the sorting, the final result that we require is that the element, if we require that should be arranged in ascending order, then they should be like 2, 9, 14, 34, 56. This is clearly the ascending order. And if we require to sort the sort the data structure in descending order, then it would be in reverse. Like it would be first element would be have been starting from 56. So this is the meaning of sorting algorithm, and the procedure that we adopt for sorting algorithm, that how to proceed with the steps that we can solve a given array in a particular order, that we will understand further. So the sorting concept is clear, I hope. Then for the implementation, different algorithms are there. Bubble sort, insertion sort, and selection sort are few of them, and they are very important and easy to understand as a beginner. If you are new to algorithms, they are easy to understand and very important. They are also implemented in our real systems. So students, first we are starting with the concept of bubble sort. So the task is same only, to arrange the elements in ascending or descending order, and we are going to have a look at how the elements, if given and we have to arrange them in a particular order, if what is the procedure of this bubble sort. The bubble sort has given what procedure that we can achieve the same that we require. So for understanding the bubble sort algorithm, let us first take a look at one example that I have taken. So students, I have taken one array, one random array I have taken. The elements are 14, 33, 27, 35 and 10. Okay. So these are in some random order. They are not, they might be arranged or they are not arranged as per now. But the array, if it is arranged only, that arranged also, that we can see manually. But if we are implementing bubble sort, that should come with a procedure, right? If you are able to see manually that the data is also arranged in an ascending or descending order, but if you are implementing bubble sort, that should in a standard way, in a procedural way, tell you that your data is arranged. Okay, so for now we are having one random array and our task is to sort this particular array in ascending order, let's say. Okay, so our final output should be like this. The first element of in the example is 14, but our requirement will be that the first element should be 10, 14, 27, 33 and 35 that are arranged in ascending order. Okay, so now student, with this example, let us clearly understand and focus on how this bubble sort works to arrange that data in the particular output that we require. Okay, so we are starting with the array, and students, take care that in this array, in this procedure, you need to maintain two variables. Okay, you need to maintain two variables that would be tracking the positions. Okay, we will be accessing the elements of this array one by one, and we know that we access the elements with the help of indexing. So we will be maintaining two variables that can help us with tracking the positions of this index that we are going on, right? Every element that we will be visiting in this array, we need to maintain that which element has been visited and we need to visit. So we need some variable, we need some tracker to maintain the same, right? So in this example, I have highlighted it. I have taken the reference of this arrow mark. So this will be telling the index position that we are currently on. Okay. So now, as I told, that we will be taking two trackers, two positions to maintain the array index, right? So the first step is first start from the first index element. Okay, so your first pointer points at the first index and access the element, right? So it is having index 0, as we have taken by default. The indexing starts from 0. Okay, let the array name be A. So we access the first element of array, that is come to be 14, sorry. Okay, and now the second tracker will also be simultaneously with this, and we find that what is the element at index 1 or second element, the corresponding immediate next element of this array. That is 33. Okay students, so now you have access to elements with the help of indexing, that is A0, 14 and A1 as 33. Now students, since we need to arrange this array in an ascending order, so your first element should be smaller, right? Right now we are comparing only these two. We are not concerned about further elements. At least these two should be in their proper arrangement, right? So we clearly know when we will compare that 14, the first element 14 is obviously less than 33. Okay, and our requirement is also that smaller element should be at first. Obviously we require 10 if we look at the whole array, but we are concerned about these two currently, right? First step, we are starting with first and immediate next index. Take care of this thing. So when we access these two elements 14, 33, 14 is less than 33. Okay, so the smallest element is already there at the previous than the larger one. Okay, so with this we stop here, and the next step, when you have visited the first index, when you are maintaining two trackers here, when you have visited the first index, immediately your pointer is incremented to the next index. Okay, so previous, that was the previously the second tracker, the second tracker has now become first, and the next immediate of second has become the second tracker for you, right? We are starting from first two index, and then in the next step, when you have compared these two and the result is okay, you increment your pointer in the further position, that is immediately next. So that was previously second becomes first, and the next one is jumps to the immediate next to the second one, right? So now here we come to index position A1, which is now first, and then the immediate next is index 2, right? If we access both of these elements, A1 comes to be 33 and A2 comes to be 27. Now students, if we compare both of these, and our requirement is to arrange in ascending order, and the element that is smaller than the previous one is behind, right? Is behind, it should be previous to the 33, right? So on comparison, we need to somehow shift this 27 to at the place of 33. Okay student, so for this type of exchange, we have understood the concept of swapping. You already know the very important concept of swapping. So somewhere in your logic you will apply this thing only. So when you found on comparing these two index positions that the element at index 2 should be previous to this one, and we need to exchange these elements within their locations, we need to swap, right? So with swapping, we now the array is like this. After swapping, 14 is not considered, we have already visited. At the current tracker positions, we swap 27 with 33 because we are doing the ascending order, and 27 is smaller than 33, so it should come first, right? So students, we also need to track the tracker positions that we are dealing with the help of which we are accessing index elements and comparing them, right? So as we have seen so far that we have visited 0 index, we have visited number 1 index, and now the first tracker comes at the second. Okay, previously that was the second tracker, now has become first because you have already visited those two elements and compared them, and if any exchange was required, we already made them, we swapped them, right? So now the index at, we come to our first index is now A2. A of 2 is 33, and the immediate next is A3, that is 35. Okay, so on comparison, 33 is less than 35, so all okay. We need no do any exchange here, right? Because the element that is smaller is already at the previous position of this element, right? So with this, when you found that no swapping is required of, or once you are done with swapping, just increment the tracker positions. So now we have visited A2, A3, and now A3 becomes first in the next step, and immediate next is fourth. So A3 is 35 and A4 is 0, 1, 2, 3, yes, 10. Okay, so when we compare 35 with 10, obviously 10 is smaller than 35 and it should be previous to this. So we need to swap here, right? So after swapping, as you can see here, I have highlighted it. So after swapping, the previous ones are not considered here. They are already done in their steps. So 14, 27, 33, and when we compare 35 with 10, so 10 has come previous to 35. Okay. Now students, in the next step, if we are incrementing our index position, so first index is now A4 and the immediate next is 5, right? So as you can see, our index elements are till 0, 1, 2, 3, 4. Indexing is only till 4. We are having 5 elements in total. Now you have incremented the tracker position and it is asking for A of 5, but with this you come to the array of bound stage, right? When it is asking for A of 5 and we are having index since till 4 only, so with this we are array out of bounds, right? So with this student, when you reach this position, when your first element is there with this index, but with this index there is no one to compare with because there is the array limit has exceeded. So we say here technically that with this first pass of this sorting is done. Okay, this is not any technical term, but as a rule it is said like first pass or first phase also, you can say first pass is done of this sorting, right? With this first pass student, our elements, as you can see manually, are still not sorted. Okay, they are still not arranged in an ascending order. That was our requirement. Okay, so first pass is done and then we start with the next stage that we say as second pass. So in the second pass students, we again start with the first element. Okay, we started with the first element, we came to the last and somewhere we exceeded the boundary, but the array was still not sorted. So we start with the second pass and we again start with the first index element. Okay, so now we are visiting again A of 0. A of 0 is now 14 and the immediate next is 27. Okay, same we need to apply every time you are accessing the elements on the indexing. We need to compare them, right? So we have two elements to compare with, 14 and 27. So on comparison, 14 is already smaller than 27 and we need not to do any exchange here, right? So we proceed further and the array that was and the element that tracker was at second position now at first now. So now we compare first as 27 and with 33. The immediate next is index 2, that is 33. So 27, 33, they are also smaller, they are also right. 27 is less than 33. So with this we again increment the index positions and we come to A of 2 as the first tracker, that is 33. And we compare with 33, the immediately next, that is 10. So 33 is not less than 10 obviously, and 10 should be before 33, so we need to do swapping as we done previously, right? So with this swapping we have 14, 27, 10 and 33, right? So these two elements visited already and they are compared, and if any swapping needed to be done, it is done already. So now the next index is now to compare with is 33 and the next one is 35. So 33 is less than 35, that is okay. On comparison, as we need it in ascending order, it is okay. So now students, again if we come to 35 as the first index position and the next will be out of bounds. So with this, the second pass of this sorting is also done. And at the end of second pass, we can see clearly that the array is still not sorted. So we start with the third pass of this sorting. Students, anytime you are starting with the phases or passes, you can say, we have to start with the very first index position only, right? So if we again access the 0th index, that is a of 0, that is 14, and we compare it with the immediately next, that is 27. So 14, 27, 14 is less than 27, that's fine. So we proceed further, increment our trackers, increment our variables that are maintaining the positions. So now the first is 27 and the immediately next is 10. So 27 and 10. 27 is greater than 10. It should be after 10 and we need to do swap here. Again the elements, again the positions are incremented and we have visited these two blocks and we are here now with 27 and immediately next 33. 27, 33 is also fine, and again the increment takes place and we compare with 33 and 35, the next one. So 33 and 35 are also fine, they are smaller than each, 33 is smaller than 35. So when we come to this 35, it will exceed the array boundary and we say that the third pass is done here. So if we check this manually, students, we can see that 14, 10, 27, 33, 35, among these 14 and 10 are also still not at their correct positions, right? So we found that we again, the next pass requirement decided by that when you are done with the pass and your array is still not sorted, right? As you can see here manually that this array is still not sorted with first two elements. So this decides that we need to start the next pass also. So with this we start with the fourth pass of this sorting, and now when we compare again, start with the first index position, that is 14, and the immediate next is 10. So 14 on comparison with 10, 14 should be after 10 obviously. So now we exchange, we swap, and with this swapping 10, 14 and are now arranged at their correct positions. Students, in any pass we need to visit the array from starting to last. Okay, if you have sorted it and you can see manually, this is not the way, because this should be implemented in program and proper procedure should be there. We are studying as algorithms. So if you are done with this swapping and you can see that the other elements are arranged, but we need to visit them. So now when we visit the further index positions, this one 14 and immediate next 27. Okay, so 14, 27, they are sorted, and as we move further, all elements that we found are sorted or arranged at their proper positions as per our requirement of ascending order. So with this, fourth pass is also done. So students, when you're here we can manually see that the elements are arranged and the pass is also done, and you think that we need not do any further passes or check, but it is not so. When we have done any even a single swapping we have done in that particular pass, we start with the final pass. Okay, as here the elements are sorted in this fourth pass, but we need to do one final pass in which all elements will again be compared from starting to end and compared with each other. So that will, and in that final pass we will not be making any swapping, because in the one before the last pass we have done this, and that after that only we have come to the final pass. Okay, so in final pass it scans the array from starting to last to check that, to ensure that all the elements are in ascending order. So in this final pass again they keep on accessing the elements from 0 to last index and comparing with the immediate next elements. So 10 will be compared with 14, 14, 27, 27, 33, 33 and 35. All will be found to be correct according to ascending order, and with this we will say that the array is now sorted. So students, this is the working of bubble sort, how bubble sort works. This is the example that I have taken. Even if you need to do descending order arrangement, we need to apply the same procedure only. That you are maintaining two trackers. They are accessing the elements from the array, the previous one and the immediate next one, and they are comparing. If on comparison you found that as per any order that you require, that the element should be before or after that particular element, so with for that purpose we need to do swapping, right? So this is the program, this is the implementation of bubble sort algorithm. This is a C program that we need to make. And students, so in this example I have taken the number of elements that the user requires and the array formed by the user only, and any array elements that the user has entered, we have to sort it, right? Some random elements has been entered by the user, as the array is having 10 elements, and we need to sort this array in ascending order. So our output should be like this. Okay, so how we will be doing it? We will be implementing the bubble sort algorithm that we have discussed manually in the form of C program to have the particular output, right? If we need to do sorting and we need to do ascending or descending order, we will implement in the form of logic and programming the steps that we have studied. Okay, so students, this is the same procedure for entering the elements of array and number of elements, that is simple input output taken by the user, that we have done previously in the arrays concept also. Now regarding the logic part of bubble sort, okay students, as we have seen that we are maintaining the passes and the tracker positions also. Okay, we need to keep the track of passes also and the tracker positions, that every time we are visiting the array elements and accessing their elements and comparing them with each other. So we will be requiring two loops here, students. So two loops I have taken, for loops. For I variable I have taken, and the next is j variable. So this first loop will be maintaining the particular pass. When you are in first pass, it will ensure that during this first pass, all the elements from 0 to the last are visited and compared with each other. Okay, so first loop will be fixed at I is equal to 0, that will indicate the first pass. Then the next pass, the next loop, for loop, will help us to access the elements on the basis of their indexing, right? So this second loop I have taken for that purpose. Then once we are inside the loop, we need to check what? We need to compare the elements, right? So you will access the array elements with the help of this indexing that you are currently on, with the help of this variable in the loop, right? So with this we need to form the condition. We need to form the condition that if this particular program is arranging in ascending order. So I have made this condition that if the element that I have accessed at j and the immediate next, that is j plus 1, is greater than, so it should come after the smaller element, right? So for this we need to do swap, and for swapping you very well know that the simple procedure, the basic, is to use the third variable. So I have done the same here. I have taken one third variable temp here and then done this exchange, done this swapping part, that if this condition comes out to be true, the second element is greater than the previous one, then for the swapping I have done these three statements. So after this sorting, it will keep in place every time it will be comparing the elements with the first and the next one, and will do the change if the condition is true. If the condition will not be true, they are already at the correct sorted position, they will come out of this condition and loop, and final, after ensuring all the passes and these array indexing position, they will come out, and finally the array will be printed. Okay students, so this was all in bubble sort algorithm. I hope this concept of bubble sort algorithm working and program is clear to you. Okay, in the next lecture we will take the next sorting algorithm, that is selection sort. So with this we end this lecture here. Thank you so much all. Keep learning.